Hey everyone, today we are diving into some incredible research that might just completely change how we build drones and maybe a lot more by looking to the natural world for some seriously high-tech materials. I know, it sounds like something straight out of science fiction, right? But what if the secret to making flying machines that are lighter, stronger, and way more sustainable isn't in some high-tech lab, but in a field of hemp, or maybe even the husk of a coconut? That's the huge question at the heart of this research. Now, to really get why this is such a game changer, we have to talk about the drones we have right now. The materials we use today, things like plastics and carbon fiber, they create a really heavy burden, not just for the drone itself, but for our planet. And it's a very real problem. It's a problem of weight, a problem of waste, and it's an environmental impact that is really holding the whole industry back. Okay, so let's break this down. Every single extra gram you add to a drone's frame means less time in the air or less stuff it can carry, whether that's a professional camera or a delivery package. On top of that, these materials are usually made from petroleum, and the way we make parts, by cutting them from big sheets, creates a ton of waste. And the worst part, when a drone's life is over, it pretty much just ends up in a landfill. There's gotta be a better way. And that better way, well, it might have been right in front of us this whole time. We're talking about using nature's own, built-in, high-tech materials. Not just copying nature's designs, but using its actual building blocks. The whole solution centers on something called biocomposites. But don't let the fancy name fool you. Think of it like this. You take these super strong, super light fibers from plants, hemp, flax, even things we throw away, like palm husks, and you mix them into a plastic that's also made from plants, like cornstarch. What you get is a material that's both a powerhouse in performance and good for the environment. And when you put them side by side, the difference is just, wow, it's night and day. You're switching from fossil fuels to renewable plants. You're making parts that are lighter. You're going from something that sits in a landfill forever to something that could actually biodegrade. And the carbon footprint, it gets slashed. It is a clear win in every single category. Now, what's so cool is that nature is the original master engineer. This quote is talking about the club of a mantis shrimp. Seriously, it's one of the toughest things in the entire animal kingdom, and it can survive these incredible high-speed impacts. And how does it do it? With a complex, layered structure of natural fibers. That's the kind of performance we can start aiming for. Okay, but having an amazing new material is really only half the story. You also need a revolutionary way to build with it, and that's where today's technology really comes into play. See, you can't just take a bunch of plant fibers and use old-school methods to shape them into a drone part. The key that unlocks all this potential is additive manufacturing, or what you and I call 3D printing. It lets us build parts layer by tiny layer, straight from a computer file. And this is just a perfect match. With 3D printing, we can create these incredibly complex shapes that are perfectly optimized for strength while using the absolute minimum amount of material. Think of lattice structures inside, kind of like our bones. And unlike old-school manufacturing, there's almost zero waste. If a design isn't quite right, no problem. You just tweak the file and print a new one in a few hours. So we have the right material, and we have the right manufacturing method. The big question is, how do we actually bring it all together? Well, that's what this research proposal is all about. It's the blueprint for making this idea a reality. The plan is so clear and methodical. First, they've got to create the perfect ink for the 3D printer, a biofilament with just the right mix of fibers and polymers. Then they'll design and print actual drone components. After that, those parts get pushed to their absolute limits with a whole battery of strength and temperature tests. And finally, they take all that data, go back to the beginning, tweak the recipe, and do it all again until it's perfect. And this chart here shows you this is not just some weekend project. This is a full-on 2-year scientific mission. Every single phase is mapped out, from the initial reading all the way to the final testing. This is a serious effort to solve a really serious problem. So what kind of performance are we actually talking about here? This is where things get really, really exciting. This chart shows us flexural strength. That's basically how much something can bend before it snaps. And look at that. The biocomposite is more than twice as strong as a standard polymer. This isn't just a greener alternative. It's a massive performance upgrade. So when you combine a material that's stronger, lighter, and more sustainable with a manufacturing process that's faster and more efficient, well, the implications are just enormous. This is about so much more than just building better drones. It's about imagining the entire future of flight. This quote from the research paper just sums up the whole grand vision perfectly. It's not just about making a better part. It's about completely rethinking the entire life of that part, from the moment it's created, the cradle, to the moment it's disposed of, the grave. And believe me, these materials are tough. One study found that a biocomposite could handle over 19,000 cycles of stress before it failed. That is exactly the kind of durability you need for the real world, where parts are constantly vibrating and under stress. And really, the ideas being developed here could scale up in a big way. Just imagine, interior panels on a commercial jet or even parts for an electric air taxi, all made from these light, sustainable materials. This research is a huge stepping stone towards greener aviation and a true circular economy, where we don't just use and throw away, but we reuse and renew. It really leaves us with a pretty inspiring question, doesn't it? For literally millions of years, nature has been perfecting lightweight, tough, and sustainable structures. And now we finally have the technology to understand them, to adapt them, and to build with them. It really makes you wonder, what other problems could we solve if we just took a look outside?